Okay, so the first example in this video, we are given a point and is on a terminal side of the angle in standard position. We want to determine the exact six trigonometric functions of this angle. So here's what we're going to do. We're going to build upon what we've already learned, maybe a little higher in complexity. So this is a positive value, so I'm going to move to the right. This is a negative value, so I'm going to drop down. So I'm literally going to go to the right and down. I'm not concerned about really how far I go to the right and how far I go down. I just want to make sure that point is in the right quadrant. This is the point 7, square roots of 5, and negative 2. Then I'm going to go straight back to the origin and always back to the x-axis, making a 90-degree angle with the x-axis. Now that angle that is closest to the origin is what I'm going to evaluate. So how did I get to this point? Well, I had to go a distance of 7 square roots of 5 to the right. And I had to go a distance of 2 down. A lot of students ask, why is it not a negative 2? Because I see a negative 2. That just tells me go in the direction of down versus up. The distance is positive, but I'm going down. Now we're going to figure out what is this hypotenuse, or the longest side of this right triangle. And so up here I'm going to start with a squared plus b squared equals c squared. Now whenever I have a square root, it doesn't matter which one of these values is the a or b. Whenever I have a square root as part of this distance, I'm going to write it twice instead of just using the square. I know a squared means a times a, so I'm going to write 7 square roots of 5 times 7 square roots of 5. And then this is going to be, again, this is going to be a distance of 2 squared. Now I could have wrote 2 times 2, but I don't see a lot of students making that mistake. Why I wrote this twice is for this reason. How do I take 7 square roots of 5 and square it, or take it times itself? Twice. 7 times 7, they're like numbers. 7 times 7 is 49. And the square root of 5 times the square root of 5 is the square root of 25. Now I know the square root of 25 is 5. So what is 49 times 5? Grab your calculator, please. I think that may be 240, but I'm not 245, but I'm not sure. Let's check. It is an answer of 245. So this is going to be 245 on the left-hand side, and 2 squared is 4. So I end up with 249. Now we need to take the square root of that, and then here's the part that's long and tedious, but it's not necessarily difficult. Before I can write the square root of 249, before I have the hypotenuse, I have to ask at this level of math, can I break it down any further? So everybody grab that calculator that I asked you to pick up. If you have not picked one up, please go and grab one. Just really quick. Raph, is this yours by chance?
Yes.
All right, here we go. Everybody type in 249. And we are going to start dividing it by perfect squares. So let's start with 15 squared. Now, a lot of you are like, well, what is 15 squared? You don't have to know it. Hit divided by. Notice I'm not putting a square root in for 249. I'm just writing 249 divided by 15 squared. Now, if I get a whole number, awesome. That means it breaks it down. And I'm just going to keep going down. Divided by 14 squared. And I want to go all the way down to 2 squared. 1 squared is not going to break anything down. Please follow along with me right now. So I'm going all the way down. I want all the females in the classroom to do 10 through 5. I want, 10 through 6. All the males, please do 5 through 2. So all females are going to go 245 divided by 10 squared. And you're going to shout out if you're able to break it down and it lands in a whole number. Again, 7 works? Awesome. You said 7 works? 3? Okay, that's great. We have to, so I heard somebody said 3, I heard somebody said 7. Let's check. Okay, 7 did not work. Let's try 3. 3 did not work. That's okay. Make sure the square. Make sure you have the square there. The square has to be included. But these, that's okay. That's all right. This is why we're doing this together. So I'm going all the way down, and then make sure you're hitting that square with it. So we're dividing by perfect squares, and I'm not seeing anything that's working. Raise your hand if you found anything else that works so far. Anything else? Nope, it doesn't. So we're going to come over here. Please make sure you're listening. This is the square root of 249. Please make sure you're listening. That's a 249 there, a little bit hard to see. All right, now we're going to evaluate the 6 trig functions. For those that often forget, it's going to be Oscar had a heap of apples. This is going to remind me, what do I do to find the sine, the cosine, and the tangent, which are the 3 primary trig functions. So let's get started. I have sine of the angle up here. Then I have cosine of the angle and tangent of the angle. I'm going to do, at the very end, I'm going to figure out what should be the proper signs on each trig function that I'm evaluating at this angle. But that's going to be at the very end. So let's start with sine. How do I figure out the sine? Sine is opposite over hypotenuse. So opposite is 2. Hypotenuse is the square root of 249. I'm going to come back and make it pretty later on. Over here, I have the square root of 249 over 2. Again, we're going to put it in proper form, making it into a pretty answer at the very end. What is the cosine? Well, cosine is going to be adjacent over hypotenuse. So I look back here, and I'm comparing the adjacent side over the hypotenuse. So it's a little bit harder. 7 square roots of 5 over the square root of 249, and then I flip it, square root of 249 over 7 square roots of 5. Tangent is going to be opposite over adjacent. Opposite is 2, adjacent is 7 square roots of 5, 7 square roots of 5 over 2. Okay, now it's time to talk about, there's 2 things we need to be concerned about. 1, in the denominator we can't have a square root, and 2, it needs to be in simplified form. We're going to start right now with each of the primary trig functions, and then we'll relate it to the secondary trig functions. Okay, are you ready? This is great mathematically, but it's not in proper form. How do I put it in proper form? 2 square roots of 249 over 249. All that's wonderful. I already know 249 cannot be broken down, but here's where you need to be concerned. There are 3 different numbers here. 2 and 249 are like terms. They don't have square roots. On your calculator, please practice with me. If you don't know in your mind how to break it down, please take 2 divided by 249. Hit math, fraction, enter, enter, and we can see it does not break down. Let's circle this and leave room for the sign at the very end. This is already in proper form, but I would like to talk about this. Students often say to me, like, can I divide these? They're not the same numbers, one the same in the same form. One has a square root, one doesn't. I can't divide them. Let's do the next one. I'm going to multiply the top and bottom by 249, the square root of 249. On the bottom, I know the shortcut is I get 249. On top, I got to figure this out. What is 249 times 5? It is 1245. Okay, are you ready? 1245. Now, I too need to check to see can 1245 be broken down. So let's grab this together and let's figure this out. Are you ready? Here we go. 1245. And you're like, where do I start? I'm kind of in the same position as you. So let's just figure out really quick. We know 25 squared is 625. I need to go beyond that probably. But when I divide it, let's start with 25 squared. So I'm going to give you guys a test. Is everybody ready? Please listen really closely. I want males to start with 25 squared, and I want you to go all the way down to 13 squared. So if I'm a male, I'm doing this. 1245 divided by 24 squared. And you're going to tell me if we see any whole number. Females, I want you to do 13 all the way down to 2 squared. 13 squared all the way down to 2 squared. I'm going to press pause for anybody that's watching this, but in my classroom, they are helping me to check, can I break this down? Again, so if I'm a male, this is what I'm doing. And if I'm a female, I'm starting at 13 down. So the students in front of me were not able to find a way to break this down. So I just need to make sure that 7 and 249 do not break down, because we can see they're like numbers. So we're going to take 7 divided by 249, hit math, fraction, enter, enter. We're like, nope, doesn't break down. How do I know? Because after I divide it, I get the same number. Circle this. Now here's the thing where you need to stop worrying. You ready? Watch this. Over here, I'm going to take times the square root of 5. I know the top. Well, 249 times 5 is 1245, and I know it doesn't break down. The square root of 5 times the square root of 5 is the square root of 25, and the square root of 25 is simply 5. So I have 7 times 5 is 35. On the bottom here, I'm going to take the square root of 5, the square root of 5, I get 2 square roots of 5 on top. Again, square root of 5 times the square root of 5 is the square root of 25, which is simply 5. 7 times 5 is 35. I know 2 and 35 don't reduce. And if you're like, well, how do I know they don't reduce? Well, take your calculator and take 2 divided by 35, hit math, fraction, enter, enter. We can see it does not reduce. Over here, it's already in proper form. If I stop now, I'm going to get this wrong. And here's the reason why. All-star trig class. All-star trig class. It lands in quadrant number 3, only cosine, and its reciprocal are positive. Positive and positive. Everything else gets one negative. Whether it's on the top, on the bottom, or in the middle, it doesn't matter as long as there's just one negative as you evaluate that particular trig function. Students in front of me right now are going to start graphing this. Remember, we're not going to be so concerned about the distance in terms of how far do I go one direction. I just know I need to go to the left, I need to drop down. So left and then drop down. What matters to me is that you're right in the right quadrant. You'll get the right answers if you're in the right quadrant, and you can reduce and find the correct hypotenuse. Okay, always back to the x-axis. Now what angle, because the angles that we evaluate with our trig functions are going to be one of these two angles, not the right angle. It's the one closest to the origin. Now what is this distance? A lot of students want to write negative 8 squared root of 2. The negative just told me go to the left. This distance is 8 squared root of 2. This distance is 3. So they are working in groups right now to find the hypotenuse, and so I'm going to do the exact same. And this part is where I see a lot of students making the mistake. So remember, we're going to go a squared plus b squared equals c squared. So the 3, it doesn't matter if it's the a or the b, so I have 3 squared. And again, some students like to do it like this. I'm just sharing with you that often, unless students expand this by writing 8 squared root of 2 times itself twice, I see mistakes. 8 times 8 is 64. The square root of 2 times the square root of 2 is the square root of 4. Well, the square root of 2 is 2. So I'm going to take 64 times 2, which is 128. So there's 138. Subtract 1 is 137. I don't think 137 can be broken down, but let's just check. For those that are in front of me, wrong answers, I just want to reiterate, wrong answers I don't care about. Speed I don't care about. Effort I care about. For those that are directly in front of me, how many of you got the square root of 137 as the hypotenuse? Okay? If not, you're going to start talking in a group right now to ensure everybody understands how to achieve the square root of 137 as this length. Okay, so you are welcome to work on your own right now, or you're welcome to listen with me if you are present in the classroom. I'm going to go over how to achieve the 6 trig functions below, provided this terminal angle. And so remember, sine is opposite over hypotenuse. So from this angle, I'm comparing and making a ratio of opposite over hypotenuse. I have 3 over the square root of 137. These two have the relationship of being reciprocals, 137 over 3. Now, cosine is going to be adjacent over hypotenuse. And then I'm going to flip it around, 137 over 8 squared root of 2. Tangent is going to be opposite over adjacent. And then I'm going to take that reciprocal and flip it. All mathematically great. I'll worry about the science at the very end, reminding myself of the acronym All-Star Trig class to decide what's positive and what's negative. Now it's time to make these pretty. So I have the square root of 137. I'm going to multiply the top and bottom by the square root of 137. I get 3 times the square root of 137 over 137. Now what I need to make sure about is I see 3 numbers. 3, the square root of 137, and 137. I already know this cannot be broken down any further. I'm looking at the 3 and the 137. I just want to make sure that it does not reduce. It can't. Okay, this is great. This is already in proper form. Cosine looks to be the ugliest of them. Let's take the top and bottom times the square root of 137. So here we go. I get 8. On the bottom I have 137. Now, what is 2 times 137? So let's take 2 times 137 and make sure I type that in correctly. And I have 274. I've got to check to see, can I break this down further? So here we go. Ready? And let's start with, I don't know, let's start with like 15 squared. And I'm just going to keep going all the way down. Okay, that doesn't work. Let's try 14 squared. That doesn't work. And I'm going to start going faster and faster here, as long as I don't make any mistakes. For those that are watching instead of actually performing this, just make sure that I'm typing this in correctly. I'm looking off to the side after I check that I've typed it in correctly to make sure that after I divide, it doesn't break down any further. For those that actually went through this, were you able to break down 274? Anybody here? So 8 times 8 is 64. We can see that does not work. Let's go 7 squared. Let's go 6 squared. It looks like it is not working. 5 squared. Make sure you're adding that square in. That could be an easy thing to forget. And I'm only going down to 2 squared. And nothing works. Okay, here we go. What does that tell me? This is 274. So when I look at those 3 terms, I just need to make sure that these like terms 8 and 137 do not reduce, and we can see it doesn't reduce because once I divide it and I hit fraction, this would reduce it if possible. It does not reduce. Now, if you pay attention to cosine, the cosecant, when I have to put it into proper form, is going to be pretty easy. What I mean by that is we already know 137 times 2. 137 times 2 is 274. I know it doesn't break apart. 2 times 2 is the square root of 4, and the square root of 4 is 2. 8 times 2 is 16. Times the square root of 2 times the square root of 2, I get 3 square roots of 2. Square root of 2 times the square root of 2 is square root of 4, which is 2. 2 times 8 is 16. 3 and 16 don't reduce. This is in proper form. If I stop now, I'm going to have this wrong. Miguel, what am I forgetting to do? All-star trig class. All-star trig class. And I'm in quadrant 3. Only tangent and its reciprocal are positive. So I get a positive, a positive. Everything else gets one negative. Now, where does that negative go? As long as you have one negative on top, on the bottom, or in the middle, 1, you will get this right. So those that are watching this video, I would like you to graph this point. So now that you have this given point, you're going to go ahead. The given point is on the terminal side of an angle in standard position, so go ahead and graph it. And then I want you to determine the exact value of the 6 trigonometric functions of that angle. Press pause, come back, and see if you have the correct answers. And if you're watching this video, these are the correct answers after evaluating this given point.